questions are from the ASA Powerplant Oral Study Guide. I'll read the questions, provide a short pause for you to formulate your response, and then read the answers. Note specific question code referencing the new ACS codes pertaining to the question will appear on the screen. The Powerplant Oral Test Guide has 13 subject areas. Let's follow along. Reciprocating engines. 1. What are the basic types or configurations of reciprocating engines? Inline, opposed, V-type, and radial. 2. In what position should the crankshaft be when a magneto is being timed to the engine? The piston in cylinder number 1 should be in the correct position for ignition to occur. This is normally about 30 degrees before top center on the compression stroke. 3. What is checked on engine run-up to determine the operational condition of the engine? Idling RPM and manifold pressure, engine acceleration, maximum static RPM and manifold pressure, magneto drop, ignition safety switch check, propeller pitch change, propeller feathering, oil pressure, and fuel flow. 4. What is a hydraulic lock in an aircraft engine? Oil has drained past the piston rings and filled the combustion chamber of cylinders that are below the center line of the engine. If the crankshaft is turned over with this oil in the cylinder, it will lock, and there is a probability that the piston, cylinder, or connecting rod will be damaged. 5. How is a hydraulic lock removed from an aircraft engine? Remove a spark plug from the lock cylinder and drain all the oil out. Clean the spark plug and replace it. 6. What are the strokes of a 4-stroke reciprocating engine? Intake, compression, power, and exhaust. 7. What are 2 main causes of a cylinder having low compression? Seating or broken, and valves not seating or burned. 8. What is a low tension ignition system? It is an ignition system using a magneto with a brush-type distributor and a coil that has no secondary wiring. Low voltage is directed from the magneto to a transformer mounted on the cylinder head. Here the low voltage is boosted to a high voltage and is directed through a very short high-tension lead to the spark plug. There is 1 transformer for each spark plug. 9. What are some advantages of a horizontally opposed engine? Low power to weight ratio, ideal for installation on aircraft wings, and low vibration characteristics. 10. How can you determine the firing order of an 18-cylinder radial engine? Begin with cylinder 1 and add 11 or subtract 7, whichever will keep the numbers between 1 and 18. 1, 12, 5, 16, 9, 2, 13, 6, 17, 10, 3, 14, 7, 18, 11, 4, 15, 8. 11. What is a floating cam ring on a large radial engine? It is a cam ring that rides on a shelf-type bearing with a large amount of clearance between the bearing and the ring. When adjusting the valves on an engine with a floating cam ring, the pressure of the valve springs on the opposite side of the engine must be removed, so the cam rings will be tight against the bearing for the valves being adjusted. 12. Why is valve clearance adjusted on radial engines but not on horizontally opposed engines? Most horizontally opposed engines have hydraulic valve lifters that keep all of the clearance out of the valve train. Radial engines have solid lifters. 13. Why are both the hot and cold valve clearances given for most radial engines? The hot clearance is given for valve timing purposes. The timing is adjusted with the valves in cylinder number 1 set with the hot clearance. When timing is set, all of the valves are adjusted to their cold clearance. 14. Why is it important to preserve engines that will not be operated for an extended period of time? Moisture will accumulate in the engine, initiating the corrosion process which can ruin the engine. Preservation for temporary storage is valid for engines that will be out of service for how many days? 30 to 90 days. 16. What should be done to the cylinders to protect them from rust and corrosion when preparing the engine for long time storage? Spray preservative oil inside the cylinders and replace the spark plugs with desiccant plugs. 17. What is the formula for calculating indicated horsepower on a 4-stroke engine? Indicated horsepower equals parentheses plank divided by 33,000, where P equals indicated mean effective pressure in PSI, L equals length of the stroke in feet or in fractions of a foot, A equals area of the piston head or cross-sectional area of the cylinder in square inches, N equals number of power strokes per minute, RPM divided by 2, and K equals number of cylinders. 18. What is specific fuel consumption? Parentheses SFC. SFC is a measure of the economical use of fuel, which is the fuel weight in pounds per hour per horsepower. SFC equals parentheses pounds fuel divided by hour divided by horsepower. 19. What must be inspected to determine the airworthiness of an engine installation? The propeller, lubrication systems, ignition systems, fuel metering systems, cooling system, and the exhaust system. 20. Where can you find the correct grade of fuel and the amount of engine lubricating oil for an aircraft engine? In the type certificate data sheets for the aircraft. 21. What are the basic steps in troubleshooting an engine installation? A. Know how the system should operate. B. Observe how the system is operating. C. Divide the system into smaller parts to find the trouble. D. Look for the obvious problems first. 22. Where do you find instructions for removing an engine from an aircraft? In the Aircraft Maintenance Manual. 23. What must normally be done to a nose wheel airplane before removing an engine? The tail of the airplane must be supported. 24. What should be used to cover the ends of fuel and oil lines that have been disconnected from the engine? The correct plugs or cabs. Never cover the end of a line with tape. 25. What is meant by a QEC engine assembly? An engine that has been prepared for a quick engine change. The engine is on its mount and all of the accessories are installed. A minimum of time is required to change engines. All that time is needed is for the controls, wiring, and fluid lines to be connected to the firewall. 26. What is meant by rigging the engine controls so they have some cushion? The control on the engine component must contact its stops before the control handle in the flight deck reaches its stops. This causes the control handle to spring back a slight amount when it is moved to the extent of its travel. 27. What are two ways of pre-oiling an engine? Plug plugs are installed, and after the oil tank or sump is filled, turn the engine over with the starter until oil runs out of the fitting to which the oil pressure gauge connects. B. Use a pre-oiler tank. Air pressure forces oil through all of the passages until some of it flows from the oil pressure gauge fitting. What checks should be made to determine the proper operation of a reciprocating engine installation? Idle RPM and mixture, static RPM, propeller pitch change and operation, magneto check, ignition switch safety check, and carburetor heat check. 29. What is the purpose of a cold cylinder check? A cold cylinder check determines which cylinder is not firing. Run the engine for a few minutes at the speed and on the magneto at which it runs roughest. Shut it down and feel the exhaust stack near the cylinder head. The cylinder with the stack that is not as hot as the other is the cylinder that has not been firing. 30. How is fuel ignited in a diesel cycle engine? The diesel cycle depends on high compression pressures to provide for the ignition of the air-fuel charge in the cylinder. Note we are now in the risk management section. Question 1. What are the risks of moving a propeller by hand during aircraft maintenance? If the ignition switch is on or a magneto ground wire is faulty, the engine can start if the impulse coupling is fired when the propeller is turned. Maintenance personnel should always verify the magneto switch is off and stay clear of the propeller arc any time the propeller is moved. 2. What precautions should be taken prior to and during ground operations of an engine? Improper procedures during ground runs can cause damage to the aircraft and injury to personnel. The maintenance manual and operational checklist should always be used when operating an engine and aircraft on the ground. 3. What are the risks associated with incorrect procedures in the event of a reciprocating engine fire? Improper procedures can lead to further damage to the engine and aircraft. If the engine backfires and causes a fire in the induction system, the starter motor should continue to run while mixture control is pulled to idle. cutoff to prevent more fuel from entering the engine. If the fire is outside of the engine, pull the mixer control to idle cutoff and close the fuel firewall shutoff valve to stop the flow of fuel into the engine compartment. After aircraft maintenance, it is good practice to have a spotter standing by with a fire extinguisher. 4. What risks are associated with using procedures other than those developed by the manufacturer? The risks of using other procedures is that important steps and procedures can be missed, causing damage to the engine, aircraft, or personnel. The manufacturer's procedures were carefully developed to maintain the type, design, configuration, and safety of the aircraft. Turbine engines. 1. How are the 4 strokes of a reciprocating engine similar to the sections of a turbine engine? Equals air inlet section. Compression equals compressor section. Ignition and power equals combustion and turbine sections. Exhaust equals exhaust section. 2. What type of turbojet engine is commonly used in commercial aviation due to lower noise and better fuel consumption? High bypass turbofan engines. 3. What 4 types of gas turbine engines are used in aircraft? Turbofan, turboprop, turboshaft, and turbojet. 4. What are the 2 types of turbine compressors? Centrifugal flow and axial flow. 5. What is meant by trimming a turbine engine? Adjusting the fuel controls so that the engine develops the correct idle and trim speed RPM. 6. What type of equipment should be used to determine that a turbine engine is performing up to the standards specified by the engine manufacturer? A jet cal analyzer / trimmer has all of the instrumentation and cables to determine the EGT, EPR, and other parameters specified by the engine manufacturer. 7. What is meant by a hot section inspection? An inspection of the hot section of a turbine engine. The hot section includes the combustors, the turbine, and the exhaust system. 8. What is meant by on-condition maintenance of a turbine engine? The monitoring of the engine performance at regular intervals and determining when maintenance is required based on certain operating parameters specified by the engine manufacturer. 9. What checks of a turbine engine are necessary to verify pre-flight conditions? A. Inspect the cowling and all air inlet areas and attachment of the engine to the airframe. B. Inspect the inlet guide vanes and the first stage of the compressor or fan blades. Check for unusual noise when the compressor is rotated. D. Inspect the rear turbine and exhaust system. E. Check the quantity of the lubricating oil for the engine and the constant speed drive unit. F. Check the ignition system for operation by listening for the sparks. 10. What engine instruments are monitored during the start of a turbine engine? Tachometer, oil pressure, and internal gas temperatures. 11. What checks are performed after the installation of a turbine engine? After starting and idle speed is obtained, the engine should stabilize, and engine instrument values are monitored. Takeoff thrust is checked by adjusting the throttle to obtain a single predicted reading on the engine pressure ratio indicator. The manufacturer's procedures and limitations must be followed during all engine operations. After engine shutdown, inspect the engine for fuel and oil leaks and general condition. 12. What engine fault could cause a turbine engine to have a high exhaust gas temperature, low RPM, and high fuel flow at all engine pressure ratio settings? And or loss of turbine efficiency due to excessive wear. 13. What would be the indications of an engine bleed air valve malfunction? Engine has higher than normal exhaust gas temperature during takeoff, climb, and cruise. RPM and fuel flow are higher than normal. 14. What is the primary purpose of bleeding air off the compressor section? To unload the compressor at low speeds and to control the flow of air to the combustion burners. 15. What is the secondary purpose or use of bleed air? Bleed air is used in a variety of aircraft systems, including cabin pressurization, heating and cooling, de-icing and anti-icing systems, pneumatic starting of engines and auxiliary drive units, and vortex dissipators. 16. How is a turbine engine preserved for long periods of inactivity? The methods will vary depending on the manufacturer and the length of inactivity. Common practices include draining the lubrication system and flushing with preservative oil. The engine fuel system may also be drained and filled with preservative oil, including the fuel control. Before the engine can be returned to service, the preservative oil must be completely flushed from the fuel system by monitoring the engine and bleeding the fuel system. Always follow the manufacturer's instructions when performing any preservation or depreservation of gas turbine engines. 17. APUs located in modern jet transport aircraft. In the tail cone of the fuselage. 18. What is the function of an APU? An APU provides electrical power and compressed air when the main engines are not operating. 19. What are two sources of compressed air from an APU? From bleed air from the APU turbine compressor or from a load compressor driven by a free turbine in the engine. 20. Where in maintenance information based on the ATA-100 system would you find instructions for inspecting and servicing the engine of an airborne APU? In section 49-20. 21. How is most of the troubleshooting done for a modern APU? By the fault codes generated by the FADEC. 22. What ensures that an APU will not be shut down while it is too hot? The APU fuel control incorporates an automatic time delay feature that closes the bleed air valve to remove most of the load and reduce the APU temperature before it is shut down. 23. What prevents the APU exceeding its safe operating limits when the bleed air valve is wide open? The FADEC monitors the load and regulates the fuel going to the APU to prevent it from exceeding its safe limits. 24. What document would you use to find the safety procedure to follow when replacing an igniter plug in an APU engine? The maintenance manual for the APU. 25. What adjustments and riggings are accomplished on a turbine engine? The primary rigging on a turbine engine involves the adjustment of power control levers and cables, followed by careful adjustment of the fuel control unit to trim the engine for the correct idle speeds and to obtain maximum thrust. Note we are now in the risk management section. Question 1. What are the risks associated with operating a turbine engine? Improper engine operating procedures can be very expensive and damage can happen quickly with repair costs of hundreds of thousands of dollars or more. Turbine engines can also create enormous amounts of thrust and the jet blast from the engine can cause damage to surrounding aircraft and ground equipment. Ground personnel must also be monitored closely to maintain proper distances from operating engines. Follow aircraft maintenance manual instructions and local safety protocols when running engines. Ground personnel must use proper PPE, including ear protection. 2. What are the risks associated with performing maintenance on a turbine engine? Improper engine maintenance can lead to expensive repairs and damage to other parts of the aircraft. Inspections and maintenance after engine runs out must be done with care due to high temperatures of the engine and components. Use proper PPE and follow all maintenance manual instructions and procedures. 3. Describe the actions to be taken to minimize damage that might occur from an engine fire. Move the fuel shutoff lever to the off position if an engine fire occurs, or if the fire warning light is illuminated during the starting cycle. Continue cranking or monitoring the engine until the fire has been expelled from the engine. If the fire persists, carbon dioxide can be discharged into the inlet duct while it is being cranked. Do not discharge carbon dioxide directly into the engine exhaust because it may damage the engine. Extinguish, secure all the switches and leave the aircraft. If the fire is on the ground under the engine overboard drain, discharge the carbon dioxide on the ground rather than on the engine. This also is true if the fire is at the tailpipe and the fuel is dripping to the ground and burning. 4. Risk of damage due to foreign object damage, FOD. Inspect inlet screens on turboprop and turboshaft engines to ensure that they are not damaged. Care should be taken when working on an engine to not allow hardware, tools, or safety wires to remain in the inlet areas of an engine. Before starting an engine, inspect the air inlet and the ground in front of and below the engine for objects and debris that can be injected into the engine. Engine inspection. Where can an aircraft mechanic find the scope and details of the engine items that must be inspected during an annual or 100-hour inspection? 14 CFR Part 43 Appendix D. 2. Who is responsible for maintaining an aircraft in an airworthy condition? The operator or owner of the aircraft. 3. What regulations specify the inspections that must be accomplished on a general aviation aircraft? 14 CFR Part 91 Subpart E. Where can you find the model of a magneto that is approved for an engine specified by the examiner? In the type certificate data sheet for the engine. 5. Where can a list of life-limited parts be found for a specific engine? In the airworthiness limitation sections of the engine maintenance manual. 6. Where can special inspection requirements be found for a specific engine? In the engine manufacturer's engine maintenance manual. 7. What is a supplemental type certificate? The FAA for a modification to a type certificated airframe, engine, or propeller. 8. When must FAA approved data be used for an engine repair or modification? When performing a major repair or modification to an engine. 9. Is a manufacturer's mandatory service bulletin required to be complied with? No, but it is recommended. 10. Which of the following are FAA approved data? Service letters, service bulletins, instructions for continued airworthiness, ADs, or TCDS? ADs and TCDS are approved by the FAA. 11. When must ADs be complied with? All ADs that apply to the affected product must be complied with in accordance with the instructions of the AD and in the timeframe specified by the AD. 12. What paperwork is necessary for the installation of a magneto that was not approved for an engine when it was certified, but it is approved for the engine when installed according to an STC? A Form FAA 337 must be completed stating that the installation was done in accordance with a specific STC. 13. Where can an aircraft mechanic find the record-keeping requirements for maintenance operations? 14 CFR Part 43. 14. Where can a mechanic find inspections, checking, and servicing requirements for a specific engine component? In the Components Maintenance Manual, (CMM) for the specific item. If the component is manufactured by the engine manufacturer, or the requirements will be found in the Engine Maintenance Manual. Where can the requirements be found for inspection and checking of engine mounts and mounting hardware? Engine mounts and hardware are typically airframe items, and the requirements will be found in the Aircraft Maintenance Manual, (not the Engine Maintenance Manual). Note we are now in the Risk Management section. Question 1. What cautions should be taken when performing a compression check on a reciprocating engine? Connecting air pressure to the cylinder can cause the propeller to suddenly rotate with force. Carefully contain the propeller prior to connecting air to the cylinder. This task is best accomplished with two people, one controlling the propeller and the other controlling the air pressure. 2. What are the risks associated with performing maintenance adjustments on an operating reciprocating engine? The danger of performing maintenance on an operating engine is the close proximity to the turning propeller that, if encountered, will cause injury or death. While the engine is operating, determine what adjustments need to be made. Turn the engine off, make the adjustments, and then start the engine back up to verify the adjustments. 3. What are the risks associated with performing maintenance on an operating turbine engine? If the turbine engine is a turboprop, the spinning propeller represents the danger. On a turbojet or turbofan engine, the dangers are the engine, inlet, and the exhaust. Follow maintenance manual instructions for making any adjustments to a turbine engine. Engine instrument systems. 1. What are three types of flow indicating systems used for turbine engines? Vane type flow meters, synchronous mass type flow meters, and electronic motorless mass flow meters. 2. What do mass flow systems measure? The mass of the flow, of the fuel, which is in turn affected by the fuel temperature. 3. In what units is an electronic motorless mass flow meter system calibrated? Pounds per hour of fuel flow. 4. What is indicated in a turbine engine if the fuel flow for all conditions is high? If there are other instrument abnormalities, there are possibly damaged turbine components. 5. Who is authorized to repair a fuel flow indicating system? The components can be repaired only by an FAA-approved repair station certified for the particular instruments. 6. Where can you find the electrical power requirements for a fuel flow indicating system? In the Aircraft Maintenance Manual. 7. Where in the fuel system is the fuel flow transmitter located? Between the fuel control and fuel nozzles. 8. What kind of indicating system is used to measure oil temperature in a small single-engine general aviation airplane? A sealed system in which a bulb particularly filled with a highly volatile liquid is installed inside the oil strainer. The bulb is contained to a pressure gauge by a copper tube. The pressure of the gas above the liquid is proportional to the temperature of the oil that surrounds the bulb, and the pressure gauge is calibrated in terms of temperature. 9. What type of instrument system is used for measuring cylinder head temperature and exhaust gas temperature? A thermocouple system. 10. What kind of electrical instrument system is used for measuring oil temperature? A ratiometer type system. 11. What should a thermocouple cylinder head temperature indicator read when the engine is cold? The same as the outside air temperature gauge. 12. What is critical in the installation of the thermocouple leads for a cylinder head temperature indicator, the length of the leads or their resistance? The resistance is critical. It must have the resistance specified on the indicator. This is usually 2 or 8 ohms. 13. What should a ratio meter temperature indicator read when the electrical power is off? The pointer should be off scale on the low side. 14. How does a ratio meter type oil temperature gauge measure the temperature of the oil? A ratio meter measures the resistance of the temperature bulb. The indicator is calibrated in degrees Fahrenheit or Celsius rather than in ohms. 15. What kind of tachometer is used on most small single-engine airplanes? A magnetic drag tachometer that is similar to an automobile speedometer. 16. What would likely cause the pointer of a magnetic drag tachometer to oscillate? Either a dry cable connecting the indicator to the engine or a kink in the cable housing. 17. What kind of tachometer is used on most large multi-engine airplanes? A three-phase AC electric tachometer. 18. What is measured to indicate the engine RPM with a three-phase AC electric tachometer? The frequency of the AC the tachometer generator produces. 19. What kind of indicator mechanism is used to measure oil pressure? A Bourdon tube. 20. What kind of indicator mechanism is used to measure manifold pressure? A differential bellows. 21. What should a manifold pressure gauge read when the engine is not operating? The existing barometric pressure as indicated on the altimeter barometric scale when the altimeter pointers are set to the surveyed field elevation. 22. What type of fitting is used to connect an oil pressure gauge to the engine? It smooths out the pulsations, and should a break occur in the indicator line, prevents a serious loss of engine oil. 23. What is used to fill the line between a fuel pressure gauge and the fuel metering system? A light oil such as kerosene. 24. What could cause a fuel pressure gauge to fluctuate? The loss of the light oil in the line between the gauge and the engine. 25. What is the range of pressure needed for a fuel pressure gauge used with a float carburetor? Normally from 1 to 25 psi. 26. What are the colors used in the annunciator indicating systems and what do they represent? Green indicates a safe condition, yellow indicates a caution alert, and red indicates a warning alert. 27. What does a torque meter measure? Most torque systems use an oil pressure output from a torque valve to indicate actual engine power output at various power settings. The torque meter indicates the amount of torque being produced at the propeller shaft. A helical gear moves back and forth as the torque on the propeller shaft varies. This gear, acting on a piston, positions a valve that meters the oil pressure proportionally to the torque being produced. 28. What does the engine pressure ratio (EPR) indicator measure? Engine pressure ratio (EPR) is an indication of the thrust being developed by a turbofan engine and is used to set power for takeoff on many types of aircraft. It is instrumented by total pressure pickups in the engine inlet and in the turbine exhaust. 29. What is an ICAS (Engine Indicating and Crew Alerting System)? ICAS is an electronic instrumentation system that monitors airframe and engine parameters and displays the essential information on a video display on the instrument panel. Only vital information is continually displayed, but when a sense parameter falls outside of their allowable range of operation, they are automatically displayed. 30. What is an engine FADEC system? FADEC (full authority digital electronic control) is a digital electronic fuel control for a gas turbine engine that is functioning during all engine operations, hence full authority. It includes the EEC, electronic engine control, and functions with the flight management computer. FADEC schedules the fuel to the nozzles in such a way that prevents overshooting power changes and over temperature condition. FADEC furnishes information to the ICAS, Engine Indicating and Crew Alerting System. 31. What is an ECAM system? ECAM (Electronic Centralized Aircraft Monitor) is a system that monitors airframe and engine function and displays them in the flight deck. It can also provide checklists for system failures. 32. What do the colors red, green, and yellow indicate on an aircraft instrument or gauge? Red indicates a maximum range or limit, green indicates a normal operating range, and yellow indicates a caution range. Note we are now in the risk management section. Question 1. What risks are associated with an inadvertent damage to an instrument or indicating system during maintenance operations? The dangers arise from incorrect readings on flight deck instruments with potential operations of the aircraft outside of design limits. Care must be taken not to damage indicating systems or instruments. 2. What are the dangers of instrument error due to failures or out of calibration conditions? Instruments that are out of calibration or have faulty indication can cause actions to be taken (or not taken) that are outside of operating parameters. Instruments are to be calibrated according to regulation and manufacturer's recommendations. Engine fire protection systems. 1. What are the engine fire zones? The power plant installation have several designated fire zones, which are 1. The engine power section. 2. The engine accessory section. 3. Except for reciprocating engines, any complete power plant compartment in which no isolation is provided between the engine power section and the engine accessory section. 4. Any APU compartment. 5. Any fuel burning heater and other combustion equipment installation. 6. The compressor and accessory sections of turbine, and 7. Combustor, turbine, tailpipe sections of the turbine engine installations that contain lines or components carrying flammable fluids or gases. 2. What different types of fires can occur in an engine compartment? On reciprocating engines, fire can occur from fuel leaks spraying on hot engine components, exhaust leaks streaming hot gases on other components, or the engine cowling in electrical faults. Turbine engine failures can cause turbine blades to melt and separate from the engine, causing damage to the exhaust duct and surrounding aircraft structure or fuel lines. A fuel nozzle that is flowing too much fuel can cause burn through of the combustion linear or tail cone. 3. What are the 4 types of engine fire detection systems? Thermoswitch systems, thermocouple systems, thermistor type continuous loop systems, pneumatic type continuous loop system. 4. Which type of fire detection system operates on the principles of the rate of temperature rise? The thermocouple system. 5. Why must the reference junction in a thermocouple fire detection system be thermally insulated? This is a rate of temperature rise system. The reference junction must be insulated so the temperature will not rise as quickly as that of the measuring junctions if a fire should occur. 6. How do you check a thermocouple fire detection system for operation? Press the test switch. This heats the test thermocouple enough for it to close the sensitive relay, which in turn closes the slave relay and activates the fire warning light and bell. 7. How is a pneumatic type continuous loop fire detection system checked for operation? When the test switch is closed, low voltage AC flows through the tube that encloses the sensitive element. This current heats the element enough for it to release sufficient gas to activate the alarm switch. 8. What would likely cause a false fire alarm in a thermistor type continuous loop system? A kinked or pinched continuous loop element. 9. If there is a break in a single wire continuous loop fire detector element and the system tests bad, will it indicate the presence of a fire? Yes, even though it tests bad, it will still indicate the presence of a fire. 10. What maintenance is allowed on a continuous loop fire detection system? Inspect and replace as needed the continuous loop element, the controller, and the fire warning bell and/or light. 11. What is used as a fire extinguishing agent in some older aircraft? Carbon dioxide. 12. What fire extinguishing agent is used in the high rate discharge bottles installed in a jet transport aircraft? Halon 1211 or 1301. 13. How is a high rate discharge bottle of a fire extinguishing agent discharged? Ignited and it blows a cutter through a fragile disc that seals the bottle. 14. What precaution must be taken when checking the electrical circuit for igniting the power charge in the valve of a high rate discharge bottle? The current used to check the integrity of the electric circuit must not be high enough to ignite the powder charge. 15. What color and marking identifies the fluid lines that carry the fire extinguishing agent in an aircraft? Brown tape with a series of diamonds on it. 16. What happens in a jet transport airplane when the fire pole T-handle for an engine is pulled? A. The engine fuel shutoff valve is closed and the generator field relay is tripped. B. The compressor bleed air valve is closed. C. The anti-ice valve is closed. D. The hydraulic supply shutoff valve is closed. E. The hydraulic pump low pressure warning lights are turned off. 17. What is indicated if the red discharge indicator for a fire extinguishing system is blown out? The system has been discharged by an overheat condition. 18. What is indicated if the yellow discharge indicator for a fire extinguishing system is blown out? The system has been discharged by actuating the bottle discharge switch. Note we are now in the risk management section. Question 1. What are the dangers associated with the handling and storage of discharge cartridges? A discharge cartridge or squib contains an explosive charge that must be stored and handled in accordance with the maintenance manual instructions. 2. Associated with extinguishing agents used in aircraft systems. Many of these systems are high-pressure systems that could cause injury to maintenance personnel. In addition, the chemicals used are considered hazardous materials and must be handled with care. Follow aircraft maintenance manual cautions and procedures when performing maintenance on or near fire extinguishing systems. 3. What precautions should be taken when working on fire extinguisher discharge cartridges? Parentheses, squibs. An electric current from the fire extinguishing circuit fires the squib. Improper procedures could inadvertently fire the explosive charge in the squib. Always follow the maintenance manual procedures when disconnecting or connecting a squib. Engine electrical systems. 1. What is used as the rectifier to produce direct current in a DC generator? Brushes and a commutator. 2. What is used as the rectifier to produce direct current in a DC alternator? 6 solid-state diodes. 3. Why is it not necessary to flash the field of a DC alternator after it has been overhauled? An alternator field is excited by battery current and residual voltage is not used to start the alternator producing current. 4. When should the brushes in a starter motor be replaced? When they have worn to 1/2 of their original length. 5. Is a starter motor series wound or shunt wound? Series wound for maximum stalled rotor torque. 6. What is a starter generator? A single engine mounted component that serves as a starter for starting the turbine engine. When the engine is running, the circuitry automatically shifts so it acts as a compound wound generator. 7. If the installed ammeter gauge is redlined at 100% of generator, or alternator rating and the regulator does not control current, how is maximum current controlled? Current is controlled by the pilot or operator of the aircraft by not applying loads greater than red line, except for short intermediate loads. 8. If placards or monitoring devices are not practical or desired, what practices protects the battery and electrical system? The generator is seized so that the total continuous load of the electrical system does not exceed 80% of the rated capacity of the generator or alternator. 9. When determining maximum continuous electrical load of an aircraft, what defines if the load is intermittent or continuous? The length of time the system is used. If the component or system is used for less than 2 minutes, it is considered an intermittent load. If it is used for more than 2 minutes, it is considered a continuous load. 10. How is generator output voltage controlled? By controlling the field current strength through the use of a voltage regulator. 11. How is the direction or rotation of a DC electrical motor reversed? Reverse the polarity of the armature or the field, but not both. 12. What must be done to a DC generator after it has been overhauled before it can produce electricity? The field must be flashed to restore residual magnetism to the field frame so it can begin to produce current. 13. How many phases of AC electricity are produced by an alternator? 3 phases. 14. How many diodes are required to convert 3-phase AC to DC electricity? 6 diodes. 15. What factors must be considered when determining wire size? A. System voltage. B. If the circuit has an intermittent or continuous load. C. Current. D. Distance in feet of the wire run. E. The temperature rating of the wire to be used. F. The ambient temperature of the area where the wire will be installed. G. The number of wires in the wire bundle. H. The percentage of time the wire bundle will be loaded. I. The maximum altitude the wire will see. 16. When paralleling the outputs of 2 generators or alternators, how close must the output voltages be? Within a few tenths of a volt. Follow the instructions in the maintenance manual for specified voltages. 17. Why is it important to parallel the outputs of a dual generator system? If the generator output voltages are not the same, one generator will attempt to carry all or most of the load, causing the generators to become overloaded. 18. What is the purpose of a generator? CSD, parentheses, constant speed drive unit. A CSD maintains the output frequency of an AC generator by maintaining the speed of the generator through varying engine speeds. 19. What is an IDG, integrated drive unit? An IDG combines the AC generator and CSD into a single unit. 20. What are 2 ways wires can be attached to the pins in a cannon plug? A. By soldering the wires into pots on the pins and sockets. B. To the wires and inserting the pins into tapered holes in the pins and sockets. 21. Why is stranded wire rather than solid wire used in most power plant electrical systems? Solid wire is likely to break when it is subjected to vibration. 22. What two things must be considered in selection of wire size when making an electrical installation in an aircraft? The current carrying capability of the wire and the voltage drop caused by the current flowing through the wire. 23. What is used to protect a wire bundle from chafing where it passes through a hole in a bulkhead or frame? A grommet around the edges of the hole. 24. How are electrical wires protected when they pass through an area of high temperature? Wires passing through these areas are insulated with high temperature insulation, and the wires are enclosed in some type of protective conduit. 25. What is the minimum separation allowed between a wire bundle and a fluid line that carries combustible fluid or oxygen? Six inches whenever possible. If not practical, the wires should not run parallel to fuel or oxygen lines, and a minimum of 2 inches must be maintained. 26. Which aircraft electrical circuit does not normally contain a fuse or circuit breaker? The starter motor circuit. 27. When should aircraft wiring be installed in a conduit? When the wiring passes through an area in the aircraft where open wiring could likely be damaged, such as through a wheel well. 28. What is meant by a trip-free circuit breaker? A circuit breaker that opens a circuit any time an excessive amount of current flows, regardless of the position of the circuit breaker's operating handle. 29. Which way should the toggle of a switch that controls the propeller pitch move to place the propeller in low pitch (high RPM)? Forward. 30. Why are protective covers placed over some switches in an aircraft electrical system? To prevent the switch from being inadvertently actuated. Note, we are now in the risk management section. Question 1. Why is it important to maintain proper polarity on components or systems when performing maintenance on electrical systems? Failure to maintain proper polarity can quickly cause damage to components and aircraft wiring. Care must be taken to observe and follow proper polarity. 2. What are the risks associated with not understanding the meaning of warning or caution lights on an annunciator panel? Not knowing or understanding the meaning of warning and caution lights can result in incorrect operation of aircraft engines and systems, faulty troubleshooting procedures, and improper repairs. 3. What cautions should be taken when performing maintenance on energized aircraft circuits and systems? An energized system can move if someone moves a flight deck control. This is more of a challenge on large aircraft when individuals working on a system cannot be seen from the flight deck. Circuit breakers should be pulled and tagged when working in an area that could present a danger to personnel. Dangerous engine components include thrust reversers, which move quickly and with much force. 4. What risks are associated with routing wire near flammable fluid lines? The danger is that lines can leak, flammable fluid can trip on wires, and fumes can be created in closed spaces. If wiring is not secured correctly, it can chafe on fluid lines or nearby structures, causing sparks and potential fire. Wiring should be rounded above flammable fluid lines and secured in a manner that prevents chafing. Engine lubrication systems. 1. What is straight mineral oil? It is a lubricating oil as obtained by fractional distillation of crude oil. It does not have any additives. 2. What is ashless disperant (AD) oil? A mineral lubricating oil containing additives that will disperse the contaminants throughout the oil so they will not clump and clog oil passages. There are no ash-forming additives in AD oil. 3. What is synthetic oil? It is made by chemically changing the nature of an oil base to give it the needed characteristics. Synthetic oil is the primary oil for turbine engines. 4. Is automotive oil suitable for use in aircraft engines? No. Automotive and aviation oils are formulated for entirely different operating conditions. 5. What is meant by multi-viscosity oil? It is a lubricating oil with a viscosity index improver that increases the viscosity of the oil when it is hot and decreases the viscosity when it is cold. 6. Where can you find the grade of engine oil specified for a particular aircraft? In the airplane flight manual or the pilot's operating handbook for the aircraft. 7. What are the 6 functions of the oil in an aircraft engine? A. Reduces friction. B. Seals and cushions. C. Removes heat. D. Cleans inside the engine. E. Protects against corrosion. F. Performs hydraulic action. 8. What is the purpose of an air-oil separator or deaerator in a turbine engine oil tank? In normal operation, the oil picks up a quantity of air and it is swirled as it enters the deaerator. The swirling action releases the air from the oil and the air is used to pressurize the oil tank. 9. How is oil pressure regulated in an aircraft engine? A pressure relief valve senses the desired pressure and sends excess oil back into the engine sump. 10. What is the purpose of the restricted orifice in the line between the oil pressure gauge and the engine? The restricted fitting helps dampen any pulsations in the oil pressure caused by the pump. 11. What is a hot tank lubrication system for a turbojet engine? A lubrication system in which the oil cooler is in the pressure subsystem and the scavenged oil is not cooled before it is returned to the tank. 12. What is a cold tank lubrication system for a turbojet engine? A lubrication system in which the oil cooler is in the scavenged subsystem and the scavenged oil is cooled before it is returned to the tank. 13. Where does a wet sump oil system store oil? In a reservoir inside the engine. 14. Where does a dry sump oil system store oil? In a reservoir outside the engine through the use of a scavenge pump and external tubing. 15. What is the purpose of a chip detector? Magnetic chip detectors are used in the oil system to detect and catch ferrous (magnetic) particles present in the oil. During maintenance, the chip detectors are removed from the engine and inspected for metal. If none is found, the detector is cleaned and replaced and safety wire. If metal is found on a chip detector, an investigation should be made to find the source of the metal on the chip. 16. What components in a reciprocating engine lubrication system must be inspected on a 100-hour or annual inspection? The oil sump or tank, the oil strainer screen, the oil filter, the oil cooler and the temperature control valve, the oil pressure and temperature gauges and any transmitters associated with them, and the entire engine for indication of oil leaks. 17. What two instruments show the condition of a reciprocating engine lubrication system? Oil pressure and oil temperature gauges. 18. What must be done to an oil filter when it is removed from the engine? It should be cut open and the pleated element examined to determine the type and amount of contaminant carried by the oil. 19. What is a spectrometric oil analysis program? A program in which a sample of oil is taken from the engine at regular intervals and sent to a laboratory where it is burned in an electric arc. The resulting light is analyzed for the wavelength of elements that are present in the oil sample. Aluminum, copper, and iron in the oil indicate wear of pistons or wrist pin plugs (aluminum), cylinder walls or piston rings (iron), or main bearings or bushings (copper). A single sample is meaningless. There must be a series of samples taken at regular intervals to measure the change in the amounts of these metals. 20. What type of oil quantity indicator is used in most aircraft engines? A dipstick that measures the quantity of oil in the tank or sump. 21. When should the engine oil quantity be checked on a turbine engine? As soon as practical after the engine is shut down. 22. Where is the oil temperature measured on a reciprocating engine? Usually at the oil pressure screen before the oil goes into the engine passages. 23. Why do engine manufacturers recommend the engine lubricating oil be changed at specific intervals? The oil picks up contaminants and carries them through the engine where they can cause wear. The oil also becomes acidic and causes corrosion in the engine. 24. What problem can improper piston rings conditioning (also known as run-in or break-in) lead to? High oil consumption. 25. What are causes of high oil consumption in a reciprocating engine? A. Failing or failed bearing. B. Worn or broken piston rings. C. Incorrect installation of piston rings. D. External oil leakage. E. Leakage through engine fuel pump vent. F. Engine breather or vacuum pump breather. No, we are now in the risk management section. Question 1. What is the danger of mixing engine oils? Oils may not be compatible with each other and can cause a degrading of the oil properties, leading to unsatisfactory lubrication of the engine. When adding oil to an engine, add the same type of oil that was used previously. 2. What are the risks of using engine lubricants other than those specified by the manufacturer? The engine was tested and certified with a specific lubricant that allowed the engine manufacturer to meet the regulations for the engine design. The use of lubricants that were not certified may lead to dangerous wear and lubrication issues in the engine, leading to premature failure. Follow the manufacturer's recommendations when using engine lubricants. 3. What cautions should be used when handling, storing, and disposing of used lubricating oils? Hazardous material that is damaging to the environment. Proper handling, storage, disposal, and recycling methods must be followed carefully. Ignition and starting systems. 1. What is the main advantage of a magneto-ignition system over a battery ignition system for an aircraft reciprocating engine? A magneto has its own source of electrical energy and it is not dependent upon the battery. 2. What is an all-weather spark plug? A shielded spark plug that has a recess in the shielding in which a resilient grommet on the ignition lead forms a watertight seal. 3. What is meant by the reach of a spark plug? The length of the threads on the spark plug that screw into the cylinder head. 4. What is the difference between a hot spark plug and a cold spark plug? A hot spark plug has a long path for the heat to travel between the nose core insulator and the spark plug shell. In a cold spark plug, the heat has a shorter distance to travel and the spark plug operates cooler than a hot spark plug. 5. What is the advantage of fine wire spark plugs over massive electrode spark plugs? Fine wire spark plugs have a firing end that is more open than that of massive electrode spark plugs. The open firing end allows the gases that contain lead to be purged from the spark plug so they will not form solid lead contaminants. 6. Why is it important that the spark plugs be kept in numbered holes in a tray when they are removed from an engine? Spark plugs tell a good deal about the internal condition of the cylinders from which they were taken. By knowing the cylinder from which each spark plug came, the mechanic can take proper action when a spark plug indicates such conditions as detonation or overheating. 7. Why is it important that a torque wrench always be used when installing spark plugs in an aircraft engine? If the spark plugs are not put in tight enough, there is the possibility of a poor seal. If they are put in too tight, there is a danger of cracking the insulation or damaging the threads on the spark plug or the cylinder. 8. What kind of gauge should be used to measure the electrode gap in aircraft spark plugs? A round wire gauge. 9. What is a shower of spark ignition systems? An ignition system that uses an induction vibrator to send pulsating DC into a set of retard breaker points on one of the magnetos. retarded spark for starting the engine. 10. What is an impulse coupling and how does it work? An impulse coupling is a spring-loaded coupling between a magneto shaft and the drive gear inside the engine. When the engine is rotated for starting, the impulse coupling locks the magnet so it cannot turn. The spring in the coupling winds up as the crankshaft continues to turn, and when the piston is near top center, the coupling releases and spins the magnet, producing a hot and retarded spark. 11. What are the three distinct circuits in a magneto system? The magnetic circuit, the primary electrical circuit, and the secondary electrical circuit. 12. What are the advantages of a solid-state magneto? No mechanical parts that wear, higher energy spark at low speeds, and no recurring inspection requirements. 13. What is the purpose of a FedEx system? FedEx, parentheses, full authority digital electronic control, is a digital electronic fuel control for a gas turbine engine that is functioning during all engine operations, hence full authority. It includes the EEC, parentheses, electronic engine control, and functions with the flight management computer. FedEx schedules the fuel to the nozzles in such a way that prevents overshooting power changes and over temperature conditions. FedEx furnishes the information to the ICAS, parentheses, engine indicating and crew alerting system. 14. What kind of electric starting system is used on many of the smaller turbine engines? A starter generator. 15. Why are air turbine starters superior to electric starters for large turbine engines? They are lightweight for the torque they produce. 16. Where does an air turbine starter get its air for starting the engines on a jet transport airplane? From an APU, GPU, or from a running engine. 17. What prevents too high an air pressure from overspeeding an engine turbine starter? The air shutoff and regulating valve. 18. Where does air turbine starter get its lubricating oil? It has a self-contained lubrication system with the oil held in the starter housing. 19. What device in an air turbine starter warns an aviation mechanic if there are any metal chips or particles in the oil? Magnetic chip detectors warn of any metal contamination in the oil. 20. What is the function of the capacitor in a magneto? The capacitor minimizes arcing at the breaking points and it speeds up the collapse of primary current as the breaker points open. 21. What happens in a magneto ignition system when the ignition switch is placed in the off position? The primary circuit is connected to the ground. 22. What is checked when a magneto is internally timed? Internally timing a magneto consists of adjusting the breaker points so they will open at the instant the rotating magnet is in its E-gap position, and the distributor rotor is in position to direct the high voltage to cylinder number 1. 23. In what position should the ignition switch be placed when using a timing light on the magnetos? In the both position. 24. What is the E-gap in magneto timing? The E-gap angle is the position of the rotating magnet where the primary current flowing in the magnetocoil is the greatest. The breaker points open when the rotating magnet is in its E-gap position. 25. What malfunction in the ignition system would cause an aircraft reciprocating engine to continue to run after the ignition switch is placed in the off position? The ignition switch is not grounding the magneto-primary circuit. 26. What type of ignition system is used on most turbine engines? High intensity, intermittent duty, capacitor discharge ignition systems. 27. How many igniters are used with most turbine engines? 2. 28. What are the two types of ignition systems used in turbine engines? High voltage systems and low voltage systems. 29. With which type of turbine engine ignition system is a glow plug igniter used? A low voltage system. 30. How is the strength of the magnet in a magneto checked? The magneto is put on a test stand and rotated at specified speed, and the primary current is measured. The strength of the magnet determines the amount of primary current. 31. In what position is the magnet in a magneto when the greatest change in the flux density in the coil core takes place? It is a few degrees beyond its neutral position. When it is in this position, the breaker points open and the primary current is interrupted. The flux change in the coil core is the greatest. 32. In what position is the magnet in a magneto when the breaker point begins to open? In its E-gap position, just a few degrees beyond its neutral position. 33. What happens when the starter switch for a turbine engine with a starter generator is placed in the start position? A. Current flows into the starter relay, which closes and actuates the ignition exciter. B. Current flows through the series motor coils of the starter generator and rotates the engine until it starts. 34. What happens when the start switch for a turbine engine with a starter generator is placed in the run position? A. The starter relay opens, shutting off current to the ignition exciter and the motor windings in the starter generator. B. The generator field relay is closed, connecting the voltage regulator to the starter generator. C. The output of the generator flows to the bus through the generator circuit breaker. 35. What is indicated if the starter relay chatters rather than locks in when the starter switch is placed in the start position? The battery voltage is too low to supply enough current to hold the relay engaged. 36. What is the purpose of the shear section in an air turbine drive shaft? If the ratchet mechanism fails to release and the engine drives the starter to a speed higher than its design speed, the shear section will break and disconnect the starter from the engine. Note, we are now in the risk management section. Question 1. What are the risks associated with incorrect retard points or incorrect impulse coupling, parentheses with a different lag angle, than what is specified by the manufacturer? Incorrectly retarded ignition can lead to a failure to start the engine or severe backfiring of the engine, which can cause damage. Use the recommended timing procedures from the aircraft maintenance manual. 2. What cautions should be taken when working around the capacitive discharge ignition systems? Capacitor discharge systems are commonly used in turbine aircraft and produce a very high energy spark. If the capacitors in the systems are still charged when the leads are disconnected, there is a danger of personnel encountering this high energy spark. Consult the maintenance manual for instructions on how long to wait after power has been disconnected before working on the system. 3. Reciprocating engines with an ungrounded magneto. Even if the propeller is turned very slowly, when the impulse coupling snaps, it sends a spark to the cylinder which can start the ignition process and start the engine. When working on an ungrounded magneto, stay clear of the propeller. Never move the propeller and if possible disconnect the ignition leads to the spark plug. Engine fuel and metering systems. 1. Why do aircraft fuel metering systems for reciprocating engines have mixture controls? The air density decreases as the aircraft ascends, causing the mixture to become richer. The mixture control allows the fuel to be decreased to maintain a fuel-air mixture ratio that produces the desired power. 2. What does an air-fuel mixture ratio of 12:1 represent? This represents an air-to-fuel mixture of 12 pounds of air and 1 pound of fuel. 3. What is the function of a flow carburetor? The flow carburetor's function is to measure airflow through the engine induction system and dispense the appropriate amount of gasoline into the airflow for all engine operating parameters and condition. It must also provide the fuel in a state that is vaporized as possible by the time ignition occurs in the engine cylinders. 4. What two things are adjusted when setting the idling conditions on a flow carburetor? A. Idling RPM by adjusting the throttle stop. B. Idling mixture by adjusting idle need valve. 5. What would most likely cause a reciprocating engine equipped with a flow carburetor to hesitate momentarily when the throttle is rapidly advanced from idle to full power? A malfunctioning accelerator pump. 6. How does a pressure type carburetor operate? A pressure type carburetor discharges fuel into the airstream at a pressure well above atmospheric. This results in better vaporization and permits the discharge of fuel into the airstream on the engine side of the throttle valve. With the discharge nozzle located at this point, vaporization takes place after the air has passed the throttle valve and at a point where engine heat tends to offset it. Thus, the danger of fuel vaporization icing is practically eliminated. The effects of rapid maneuvers and rough air on the pressure type carburetors are negligible since its fuel chambers remain filled under all operating conditions. 7. What are the two types of fuel injection systems used on modern reciprocating engines? Teledyne Continental (TCM) system and Precision Air Motive (Bendix) systems. 8. What is used in the TCM fuel injection system to control the amount of fuel sent to the nozzles? The engine speed determines the injector pump output pressure. The relief valve determines the fuel for low-speed operation, and the adjustable orifice determines the fuel for high-speed operation. 9. What is used in the Precision Air Motive system to control the amount of fuel sent to the nozzles? The engine acts on an air diaphragm that controls a servo ball valve in the line between the regulator and the flow divider. 10. What is a FEDEC? A full authority digital electronic control (FEDEC) is a high-precision digital electronic fuel control that functions during all engine operation. It includes the electronic engine control (EEC) and functions with the flight management computer (FMC) to measure the fuel to the nozzles in such a way that prevents overshooting the power changes and over temperature conditions. FedEx furnishes the information to the engine indicating and crew alerting system. Parentheses ICAS. 11. Does a turbine engine controlled by FedEx require manual trimming? No, this is done by the FedEx. 12. What are the basic principles of a hydromechanical fuel control? A pure hydromechanical fuel control has no electronic interface assisting in the computing or metering the fuel flow. It is also generally driven by the gas generator gear train of the engine to sense engine speed. Other mechanical engine parameters that are sensed are compressor discharge pressure, burner pressure, exhaust temperature, and inlet air temperature and pressure. Once the computing section determines the correct amount of fuel flow, the metering section through cams and servos valve deliver the fuel to the engine fuel. What are the two basic types of fuel nozzles? Simplex and duplex configurations. 14. Why does a duplex fuel nozzle usually require a dual fuel manifold? The duplex nozzle usually requires a dual manifold and a pressuring valve or flow divider for dividing primary and secondary parentheses main fuel flow. 15. What is the advantage of a duplex fuel nozzle? The duplex nozzle offers a desirable spray pattern for combustion over a wide range of operating pressures. 16. What parameters are normally sensed by a turbine engine fuel control? A. Power level angle. B. Compressor inlet total temperature. C. Compressor RPM. D. Burner pressure. 17. What is meant by trimming a turbine engine? Adjusting the fuel control for the proper specific gravity of the fuel and for the proper idle and full throttle RPM. 18. What are two types of electronic fuel controls for the turbine engines? Supervisory electronic engine control and full authority digital electronic control. 19. What position should the flight deck fuel metering control parentheses or fuel condition lever be set for starting a turbine engine? The normal starting sequence is 1. Rotate the compressor with the starter. 2. Turn the ignition on. And 3. Open the engine fuel valve either by moving the throttle to idle or by moving a fuel shutoff lever or turning a switch. 20. What specifications are used to trim a turbine engine? The data plate specifications for the specific engine. This data was obtained when the engine was calibrated in the manufacturer's test cell. 21. Where should ambient temperatures be measured when trimming a turbine engine? In a shaded area as near the engine inlet as is practical. 22. When should a turbine engine be retrimmed? Anytime there is a decrease in engine thrust and after any maintenance that the manufacturer specifies as requiring retrimming. 23. Are the instruments installed in an aircraft suitable for use when trimming a turbine engine? No, a special analyzer / trimmer such as a jet cowl should be used. 24. Where are the fuel strainers normally located in an aircraft fuel system? Fuel strainers are located in the tank outlet. The main strainer is located at the lowest point in the fuel system, and there are strainers in the carburetor or fuel injection system. 25. How can you tell when a fuel strainer for a turbine engine has been bypassed? There is an indicator button that will pop out. This button is usually painted red for easy identification of a bypass condition. 26. What are the two types of fuel heaters used in a jet transport aircraft? Air-to-fuel and oil-to-fuel heat exchangers. 27. How are fuel lines often protected in an aircraft engine compartment? By wrapping the lines with a fire protection sleeve to protect from fire and abrasion. 28. What is the purpose of a ley line, parentheses solid line or printed words, on a flexible fuel hose? To monitor fuel hose twist. Hoses should be installed without twisting. 29. What kind of fuel boost pumps are normally installed inside the fuel tanks? Centrifugal pumps. 30. What are the three functions of the boost pump in the tank of a jet transport aircraft? A. To pressurize the fuel in the line between the tank and the engine-driven pump. B. To transfer fuel from one tank to another to balance the fuel load. C. To pump fuel from the tank into the dump chute when fuel is being dumped. 31. What is meant by a compensated fuel pump? It is a fuel pump that senses the ambient air pressure and maintains the fuel pressure a specific amount above this air pressure. 32. What are the two types or categories of engine-driven fuel pumps? Non-constant displacement and non-positive displacement. 33. What are the three basic types of valve used in fuel system? Cone type, poppet type, and gate valves. 34. What are the three most common types of fuel filters? The micron filter and the wafer screen filter and the plain screen mesh filter. 35. Why do some aircraft filters have a relief valve? If the fuel screen or filter becomes clogged, the relief valve will allow fuel to continue to flow to the engine. 36. Where are fuel drains located in an aircraft engine? On a turbine engine, combustion chambers have a drain valve that drains fuel that accumulates in the combustion chamber after each shutdown or any fuel that may have accumulated during a false start. Many reciprocating engines have drain valves in the intake manifold that open when the engine is not running. These drains remove excess fuel if the engine is flooded from overpriming or an unsuccessful engine start. No, we are now in the risk management section. Question 1. What risks are associated with incorrect adjustments of a turbine engine fuel control unit, parentheses FCU? Problems can occur if the air fuel control unit on a reciprocating engine is not adjusted correctly. If the fuel control unit is not adjusted correctly, the engine may not reach full power, the engine could run rough, or the engine could die at low power settings due to incorrect air-fuel ratios. 3. What dangers are present when the handling of fuel metering system components results in fuel spillage on the hangar floor? Fuel spilled on the floor represents a danger for the fuel fumes, is a hazard for personnel to slip on, and has a deterring effect on tires that are spilled on or that roll through the fuel. Any tire that is contaminated should be cleaned with soap and water and dried. Fuel spills should be addressed immediately. 4. What considerations or precautions should be taken when performing maintenance on fuel systems? Care should be taken to not breathe in fuel vapors and not allow fuel to remain on exposed skin. Use proper PPE when working on fuel systems. Spilled fuels should be cleaned up immediately. Fuel should not be allowed to drip on paint, tires, or any rubber components as damage can occur. 5. What risk associated with spilling fuel when handling a fuel control unit? Fuel spilled on the floor represents a danger from the fuel fumes, is a hazard for personnel to slip on, and has a deterring effect on tires that are spilled on or that roll through the fuel. Any tire that is contaminated should be cleaned with soap and water and dried. Fuel spills should be addressed immediately. Reciprocating engine induction and cooling systems. 1. Engine that prevents the loss of induction air if the air inlet filter should be covered with ice. A alternate air valve allows warm air from the inside of the engine cowling to flow into the fuel metering system. 2. What would be the effect on engine operation of an air leak in the intake pipe for one cylinder? That cylinder would run lean and detonation could occur. 3. What must be inspected on the cooling systems of an air-cooled engine? All of the baffles and air seals must be in place and in good condition. 4. Why should an air-cooled engine not be run up to high power without the cowling installed? The engine depends on the cowling to force air through the cylinder fins to remove the excess heat. 5. Why do some air-cooled engine installations have cowl flaps? Cowl flaps produce a low pressure on one side of the engine to pull air through the cooling fins on the cylinders. 6. What document describes the proper use of cowl flaps on an air-cooled engine? The Pilot's Operating Handbook. 7. Why does ice form in the throat of a float carburetor? When liquid fuel evaporates, it absorbs enough heat from the air to cause moisture to condense out and freeze. 8. Are internally driven superchargers located before or after the carburetor? Compress the air-fuel mixture after it leaves the carburetor, while externally driven superchargers (turbochargers) compress the air before it is mixed with the metered fuel from the carburetor. 9. What are the three main parts of a typical turbo supercharger? Compressor assembly, turbine wheel assembly, and full floating shaft bearing assembly. 10. How is a turbo supercharger (or turbocharger) driven? Derive their power from the energy of an engine exhaust gases directed against a turbine that drives an impeller that compresses the incoming air. 11. How is a supercharger driven? The supercharger is directly driven from the engine and is internal to the engine. 12. An augmenter system increases cooling airflow over a reciprocating engine. Augmenters use exhaust gas velocity to cause airflow over the engine so that the cooling is not entirely dependent on the prop wash. 13. Why is it very important that the induction air filters be kept clean and replaced as often as the manufacturer recommends? Clogged air filters can restrict the air entering the engine. 14. Does the application of a carburetor heat cause the fuel-air mixture to become richer or leaner? The less dense heated air draws the same amount of fuel from the carburetor as cold air, therefore the mixture becomes richer. 15. What happens to engine RPM when carburetor heat is applied? The RPM drops. 16. Why should the use of carburetor heat be limited when operating an engine with the aircraft on the ground? The air that flows into the engine when carburetor heat is applied is not filtered. 17. Why is a fuel-injected reciprocating engine not as prone to icing as an engine equipped with float carburetor? In a fuel-injected engine, the liquid fuel evaporates in the intake valve chamber of the hot cylinder head. In the carbureted engine, as air flows through the carburetor venturi, the pressure drops, decreasing temperature and increasing the chances of icing. 18. What creates the pressure of the air in a pressure cowling? The forward velocity of the airplane as air enters openings into the cowling and flows into the engine compartment. 19. What is meant by pressure cooling of an air-cooled engine? Ram air on one side of the engine is forced by a series of baffles to flow through the pins on the cylinders to a low pressure area on the other side of the engine. Controls the amount of air cooling in a pressure cowling system. The exit air is controlled through the use of cowl flaps. The cowl flaps are open to allow more airflow and more cooling. The cowl flaps are closed to reduce the amount of airflow over the engine. 21. What is the purpose of engine baffles and seals in a pressure cowling system? The baffles and seals cause the air to be directed over the cooling fins on the cylinders. 22. Where can you find what is the maximum amount of cylinder fin area that can be removed in order to clean out a damaged area? In the engine overhaul manual. 23. How is heat removed from the liquid in a liquid-cooled engine? By flowing air over a radiator. Note we are now in the risk management section. Question 1. Why is it important to follow proper maintenance procedures on a turbocharger? Turbochargers rotate at high speeds and generate significant amounts of heat. Proper oil flow and control through a turbocharger is critical for cooling and control of the turbocharger system. Improper maintenance leads to improper operation and early failure of the system. 2. What are some of the risks associated with ground operation of aircraft engines? The cooling of aircraft engines is optimized for in-flight operations. Ground operations do not provide sufficient air to provide the same amount of cooling, and engines can overheat. Follow maintenance manual procedures for ground operations and monitor engine temperatures to prevent the engine from overheating. 3. What are the risks of maintenance-related fraud and how can it be prevented? Maintenance-related fraud can come in many different forms. Tools that are laid down on top of an engine or in the inlet duct of a turbo engine can quickly enter the engine and cause major damage to the engine. Other sources of fraud include hardware, safety wire, protective caps, and items falling out of aviation mechanics' pockets, all of which can cause damage to an engine. 4. What cautions are to be taken when servicing a liquid cooling system? The chemical used in coolants can be harmful if ingested and can cause irritation to exposed skin. Use proper PPE when working on cooling systems. Coolant can also be harmful to tires and rubber components on the engine. Clean up spilled coolant immediately. Turbine engine air systems. How is a turbine engine cooled? A turbine engine is cooled by the air passing over and through the engine. On a turbofan engine, a large portion of the air flows over the outside of the engine, helping to cool the various sections of the engine. 2. Why is it important for turbine engines to have a relatively distortion-free flow of air to the inlet of the compressor? A uniform and steady airflow is necessary to avoid compressor stall. Airflow tends to stop or reverse direction of flow, and excessive internal engine temperatures in the turbine section. 3. How are the high internal temperatures of a turbine engine cooled and kept under control? A portion of the air flowing into the engine flows around the combustion chamber and even around the internal combustion flame to contain the flame and protect internal components of the engine. 4. What are the baffles used in the airflow of a turbine engine? To direct cooling air to protect engine and airframe components, the combustion chamber is a specialized baffle that directs compressed air into the combustion chamber and helps contain the flame. 5. What is the purpose of insulation blankets in a turbine engine installation? Although insulation blankets protect the fuselage from heat radiation, they are used primarily to reduce heat loss from the exhaust system. The reduction of heat loss improves engine performance. 6. What is the primary design concern of a turbine engine inlet? The air entrance is designed to conduct incoming air to the compressor with minimum energy loss resulting from drag or ram pressure loss. That is, the flow of air into the compressor should be free of turbulence to achieve maximum operating efficiency. Proper inlet design contributes materially to aircraft performance by increasing the ratio of compressor discharge pressure to duct inlet pressure. 7. What is the compressor pressure ratio? This ratio is the outlet pressure divided by the inlet pressure. The amount of air passing through the engine is dependent upon three factors. 1. The compressor speed (RPM). 2. The forward speed of the aircraft. 3. The density of the ambient (surrounding air). 8. Where is the bleed air taken from on a turbine engine? Bleed air is taken from any of the various pressure stages of the compressor. Air is often bled from the final or highest pressure stage since at this point pressure and air temperature are at a maximum. 9. What are some of the uses of bleed air? A. Cabin pressurization, heating and cooling. B. De-icing and anti-icing equipment. C. Pneumatic startings of engines. D. Auxiliary drive units (ADU). E. Vortex dissipators. 10. How is ice prevented from forming on the nose cowl, nose dome, and inlet guide vanes of a turbine engine? Hot compressor bleed air flows through the passages in these components to elevate the surface temperatures insufficiently to prevent ice from forming. Note we are now in the risk management section. 1. Why is it important to follow manufacturer's instructions when maintaining compressor bleed air system? Poor maintenance can lead to bleed air valve malfunctions, which can cause high exhaust gas temperatures during takeoff, climb, and cruise with higher than normal RPMs and fuel flows. 2. What risks are associated with ground operations following other than the manufacturer's instructions? Failure to follow the manufacturer's instruction can lead to safety issues and hot or hung starts. The manufacturer's operating instructions should be consulted before attempting to start and operate any turbine engine. Prior to start, particular attention should be paid to the engine air inlet, the visual condition and free movement of the compressor and turbine assembly, and the parking ramp area forth and aft of the aircraft. During the start, it is necessary to monitor the tachometer, the oil pressure, and the exhaust gas temperature. The normal starting sequence is 1. Rotate the compressor with the starter. 2. Turn the ignition on. 3. Open the engine fuel valve either by moving the throttle to idle or by moving a fuel shutoff lever or turning a switch. Engine exhaust and reverser systems. 1. How does a leak appear in an engine exhaust system? It normally looks like a gray or black feather-shaped streak coming from a crack or from a location where components are not in perfect alignment. 2. How can you check a reciprocating engine exhaust system for leaks? Pressurize the exhaust system with a discharge from a vacuum cleaner and wipe a soap solution over all joints and suspect areas. A leak will cause bubbles to form. 3. How do the components in the exhaust system of a turbocharged engine allow for the expansion and contraction due to heat and at the same time prevent leakage? Bellows and ball joints prevent leakage while allowing contractions and expansion. 4. Should a turbocharged engine be started with the wastegate open or closed? Open, so as much exhaust as possible will bypass the turbine. 5. What is the primary function of a reciprocating engine exhaust system? Its main function is to dispose of the gases with complete safety to the airframe and the occupants of the aircraft. The exhaust system can perform many useful functions, but its first duty is to provide protection against the potentially destructive action of the exhaust gases. 6. What is a short stack exhaust system? The short stack exhaust system utilizes open exhaust tubes with no mufflers. The short stack system is generally used on a non-supercharged engines and low-powered engines where the noise level is not too objectionable. 7. How is exhaust flow different in a ducted fan turbine engine versus an unducted fan engine? Ducted fan engines take the fan airflow and direct it through a closed duct along the engine. Then it flows into a common exhaust nozzle. The core exhaust flow and the fan flow mix and flow from the engine through the mixed nozzle. The unducted fan has two nozzles, one for the fan airflow and one for the core airflow. These both flow to ambient air separate from each other and have separate nozzles. 8. What is the purpose of an augmenter on reciprocating engine exhaust system? The augmenters are designed to produce a Venturi effect to draw an increased airflow over the engine to augment engine cooling. 9. How does the reciprocating engine muffler decrease engine noise? Exhaust gases from the cylinders are combined into a common manifold that contains a section of the exhaust where the volume increases (expansion chamber), slowing the gases down, diffusing the flow through internal baffles, and reducing the noise. 10. What is a jet aircraft hush kit? A hush kit is an aerodynamic device that diffuses the flow of exhaust from the older turbojet engines by reducing the noise caused by high-velocity jet exhaust. 11. Why are thrust reversers not normally used when the airplane is moving below approximately 60 knots? There is a danger of recirculating the exhaust gases and of the engine ingesting foreign objects stirred up by the high-velocity gases. 12. What is a mechanical blockage thrust reverser? A thrust reverser that slides a pair of scoop-shaped doors aft and opens them so they block the rearward flow of gases and deflect the gases forward. 13. How does a cascade-type thruster reverser operate? A portion of the fan cowl moves rearward and a series of blocker doors deflect the fan discharge air through fan cascades that direct the discharge air forward. At the same time, blocker doors shut off of the flow of gas from the core engine and deflect it through the cascades that direct it forward. Note we are now in the risk management section. 1. What risks are associated with exhaust systems? Maintenance and inspection on reciprocating engine. Exhaust systems become very hot during operation and the components will remain heat soaked after shutdown. Wait for the components to cool down sufficiently before working on them and wear proper gloves to protect against burns. Another challenge of inspecting exhaust system is that internal baffles and diffusers can be difficult or impossible to see without partial disassembly of the exhaust system. It is important to understand the exhaust system and understand the procedures needed for proper inspection. 2. What dangers are associated with performing maintenance on thrust reversers? Thrust reversers can move quickly with much force. Personnel must remain clear during ground checks and measures should be put in place to ensure that the system is not inadvertently energized. 3. What dangers exist with operating reciprocating engines with exhaust leaks? Exhaust leaks are particularly dangerous as hot gases can cause damage to aircraft structure and other engine systems. If the exhaust leak is in the cabin heat exchange area, carbon monoxide can enter the cabin and render the occupants unconscious. 4. What type of damage is most common in the exhaust system of a reciprocating engine? Cracks caused by expansion and contraction. 5. What is the danger of an internal failure of baffles and diffusers in an exhaust muffler? Internal failures can cause sections of baffles and diffusers to break off and block the exits of the exhaust, causing loss of engine power. During inspection of the exhaust systems, it is important to inspect the internal portions of the mufflers. 6. What risks are associated with exhaust systems during ground operations of aircraft engines? Aircraft engines are designed for operation in flight. Ground operations do not provide the same amount of cooling of exhaust systems as when the aircraft is in flight. Extended grounding operations can introduce overheat conditions that are difficult to detect and may cause damage to the engine and exhaust systems. Follow maintenance manual procedures for the ground run operation to reduce risk of damage. Propellers. 1. Why do some aircraft engines have a critical range of operation? The engine and propeller combination have a resonant frequency problem in which excessive vibration can occur in certain range of RPM. The chronometer for an aircraft with this limitation is marked with a red arc. When it is necessary to pass through this range, it must be done as quickly as practical. 2. Does the centrifugal twisting moment on a propeller blade tend to move the blades toward high pitch or towards low pitch? Towards a low pitch. 3. Do the counterweights on a propeller tend to move the blades towards high pitch or towards low pitch? Toward high pitch, with some Macaulay feathering propellers. The accumulator stores oil under pressure when the engine is operating normally. This oil is used to help the propeller blades move towards low pitch when the propeller is being unfeathered. 5. Range of operation of a turboprop propeller. This is the in-flight mode of operation from takeoff to landing. 6. Should an adjustable pitch propeller be in high pitch or in low pitch for takeoff? In low pitch. 7. What can be done to prevent the front cone from bottoming when installing a propeller on a splint shaft? Install a spacer behind the rear cone to move the propeller forward on the shaft. 8. Why is the propeller indexed to the engine crankshaft? The relationship between the propeller and the engine crankshaft is chosen to produce the minimum vibration. 9. What is the function of the snap ring inside the hub of a propeller that is mounted on a tapered or splint shaft? The snap ring allows the propeller to be pulled off of the shaft when the retaining nut is backed off. 10. What are the basic types of propellers? Fixed pitch, ground adjustable, constant speed non-feathering, and constant speed feathering. 11. What materials are propeller blades made from? Wood, aluminum, and composite construction. 12. For a constant speed propeller to change the speed at which the propeller is operating. The compression of the speeder ring. 13. What is done to cause a Macaulay propeller to feather? Oil is allowed to drain out of the propeller. 14. What keeps a Macaulay feathering propeller from feathering when the engine is shut down on the ground? A spring-loaded latch mechanism prevents the blade moving into the feather position when the engine is shut down on the ground. In the air, aerodynamic forces keep the propeller rotating fast enough that the centrifugal force holds the blades unlatched so that they can move to the feather position when oil pressure is taken out of the propeller. 15. Automatic propeller to feather. High pressure engine oil is directed into the propeller through the governor. 16. What does the pilot do to change the RPM of an engine equipped with a constant speed propeller when it is operating within the constant speed range? The propeller pitch control. This changes the compression on the speeder spring inside the governor, which moves the pilot valve. The pilot valve directs oil into or out of the propeller to change the pitch of the blades. The change in the pitch changes the air load on the propeller, which changes the RPM. 17. What is the difference between a controllable propeller and a constant speed propeller? Basically, it is the control system. A controller pitch propeller uses a manually operated oil valve to control the pitch, and a constant speed propeller uses a governor to control the valve. 18. When making a magneto check on an engine equipped with a constant speed propeller, should the propeller control be in the low pitch or in the high pitch position? It should be in the low pitch, high RPM position. 19. What is meant by the beta range of operation of a turboprop propeller? This is the mode of ground operation, and it includes starting, taxiing, and ground reverse operation. 20. What controls the blade angle of a propeller when operating in the beta range? When operating the beta range, blade angle is controlled by the position of the power level. 21. Where do you find a list of the lubricants that are approved for use in a constant speed propeller? In the maintenance manual for the propeller. 22. What is the extent of the repairs a mechanic with a powerplant rating can make to a propeller? Only minor repairs or minor alterations. 23. Where can examples of acceptable repairs to aluminum alloy propeller blades be found? In AC 43.13-1B, Chapter 8, Section 4, and in the Propeller Manufacturer Service Manual. 24. Is it permissible to cold straighten a damaged aluminum alloy propeller blade to facilitate ship it to a repair station? No, this could cause hidden damage that may render the blade non-repairable. 25. What would be the classification of maintenance for shortening a propeller blade? Major repair. 26. May transverse cracks in a metal propeller blade be repaired? No. A transverse crack of any size is reason for rejecting the blade. 27. What damage to an aluminum alloy propeller blade can be repaired by a mechanic holding the powerplant rating? Small roughness, nicks, and scratches in the leading edge of the blades. 28. How are small nicks removed from the leading edge of a propeller blade? File them out of a fine file or stone, leaving a smooth contour. 29. How can you determine that a surface scratch in an aluminum alloy propeller blade is not actually a crack? Clean the damage out to a saucer-shaped depression and spray the area with dye-penetrant liquid. Allow it time to seep into the crack. If one is present, then wipe all of the liquid off the surface. Spray the area with a developer. If the damage is actually a crack, the developer will pull the penetrator out and it will form a visible line. 30. Who or what facility is authorized to perform major repairs to a propeller? An FAA-approved propeller repair station that is authorized for the specific propeller. 31. What checks and maintenance is a mechanic with a powerplant rating allowed to make on a propeller? Check the track of the propeller blades, remove small nicks and scratches from the blades, check the dynamic balance of a propeller, lubricate the propeller. 32. What adjustments can a mechanic with a powerplant rating make to a propeller governor? Adjust the maximum RPM stop. 33. What instrument is used to measure the blade angle of a propeller? A universal propeller protractor. 34. Where is the propeller protractor placed to measure the propeller blade angle? At a distance from the center of the propeller hub. This distance is specified in the propeller maintenance manual in terms of the propeller blade stations. 35. What are the basic steps for removing a typical propeller? 1. Remove the spinner and remove safety wire from the mounting bolts. 2. Support the propeller with a sling and mark the alignment between the propeller's hub and the engine flange with a felt tip pen. 3. Unscrew the mounting nuts and protect the threads of the mounting studs or bolts as the propeller is removed. 4. Place the propeller on a cart for transport. 36. What alignment method is used to align a propeller to the engine in position that reduces operating vibrations? Special studs or dowel pins align the propeller to the engine in proper orientation. 37. Who is allowed to reduce the diameter of a type certificated propeller? An FAA certificate propeller repair station with approval for the particular propeller. 38. What type of certificate data sheet (aircraft, engine, or propeller TCDS) specifies that a propeller can be installed on the aircraft in question? The aircraft TCDS specifies which propellers are approved for installation. 39. What is meant by a slave engine with regard to propeller synchronization? This is the engine in a multi-engine airplane whose RPMs follow those set on master engines. 40. How are propellers on a twin-engine airplane synchronized? The propeller governor of the master engine is set to the desired RPM. A signal from the master engine governor is sent to the control box, which sends a signal to a stepping motor. This motor adjusts the propeller governor and fuel control of the slave engine, causing it to maintain exactly the same RPM as the master engine. 41. How is ice prevented from forming on propeller blades? A chemical anti-icing system is used. A mixture of isopropyl alcohol and ethanol glycol is pumped into a slinger ring on the back of the propeller hub. From there, centrifugal force slings it out along the blades. Ice cannot form on the resulting slick surface. 42. How is ice removed from the propeller blades? An electrothermal de-icing system is used. Electrical heating elements are embedded in rubber boots that are bonded to the leading edge of the blades. Low voltage DC flows from the propeller de-icer control through brushes and slip rings to the heating elements. The timer sends current to one propeller for about 90 seconds and then to the other for the next 90 seconds. This allows the ice to form and then break loosely and blow away. 43. How can you determine that the electrically heated de-icer boots on the propeller blades are working as they should? Observe the load meter or ammeter to see if the proper current is flowing, and flow the sequence of boot heating by feeling with your hands to see which one is heating. The boots should all have a similar heat rise in the same length of time. Note we are now in the risk management section. 1. What dangers are present when operating a propeller on the ground? Propellers become almost invisible when spinning rapidly and may not be visible to individuals close to the airplane. Measures must be in place to prevent people from approaching the airplane when the engine is running. Propeller blast is also a potential danger that can cause damage to equipment or other aircraft that are behind the running engine. Before starting an engine, the aviation mechanic must use caution and understand what is behind the operating engine. In addition, the area below and in front of the propeller must be checked for gravel, small rocks, and other items that can become thawed and damage the propeller when the engine is started. 2. What is the critical nature of propeller maintenance and inspection? The loads on a spilling propeller are extremely high. Small damage and improper maintenance can lead to catastrophic damage to the aircraft due to failure of the propeller. Maintenance manual procedures must be followed at all times. Thank you. That is the end of the propeller oral study guide questions. I wish you luck. Please don't forget to subscribe, share, and comment. And also, if you want the book, the link is in the description.